this is the recorded version for our second lesson for our prelim, which is entitled Forces Acting on a Propeller and Propeller Design. So here are the following topics that we will be discussing. We have a total of 8 major topics, and the ninth part will be pretty much about our assessments, activities, or any announcement for like quizzes and such. So a total of we have 9 agendas for this meet. So the first one, we have propeller aerodynamics, then followed by propeller twist, followed by the forces acting on a propeller, and the stress acting on it, and the vibration, basic principles of propeller, propeller pitch, propeller design, and the last part. Okay, first we will have propeller aerodynamics. To begin with the discussion for propeller aerodynamics, let's have a recall first. I remember asking the same question in our first discussion. How do propellers produce thrust? Okay, so the answer for this one is pretty much by converting rotational energy again into propulsive force. This is the process on how it creates thrust, which is approximately perpendicular to its plane of rotation. Again, since we know na same na airfoil sections ang ginagamit for both propellers and the wings for the fixed wing, can we say that, or rather, can we apply the same idea as to how the wing generates lift to how propellers generate thrust? Again, this is just a recall since this is a question then sa last nating lesson. And yeah, the answer again for that is yes. Same principle lang siya. Meron tayong low pressure on top and high pressure underneath. The difference in pressure will give us lift, which counteracts again the weight. And we have then our drag, of course. Now, with the propeller naman, we still have that airfoil shape, giving us the same theory sa propeller natin. But this time, again, just a recall, we don't call it lift and drag anymore. We call it thrust and torque. And normally, thrust and torque again is shown as the third photo. I believe we discussed na din naman na for this part, hindi na siya angle of incidence, just like the fixed wing. Tawag na sa kanya is propeller blade angle, yung angle na nafo-form ng chord line and again, yung plane of rotation. So, all of this is in line with Newton's third law. The amount of thrust a propeller produces depends on the air mass and its acceleration towards the rear. Thus, with equal RPM, the smaller propeller delivers less thrust than the larger one. Let's have another figure right here. Okay. So, a spinning propeller creates lower static pressure in front of it and higher behind it. So, propellers generate lift in a forward direction rather. So, this photo is a representation lang in a bigger perspective ng theories na na-discuss natin. Additionally, in NASA's terms, a spinning propeller sets up a pressure lower than free stream in front of the propeller and higher free stream rather behind the propeller. So downstream of the disk, the pressure eventually returns to free stream conditions. But at the exit, the velocity natin is greater than the free stream. Because pretty much the propeller does work on our airflow. So we can apply basically yung ating Bernoulli's equation to the air in front of the propeller and to the air behind the propeller. So later on, may i-introduce tayong mga equations and makikita nyo yung relationship niya and application syempre ng ating Bernoulli's. So That is not all of the propeller aerodynamics, but that's pretty much the introduction to it. Now, as we move forward pa sa ating mga topics, especially when we reach the computations part, we would get to it pa. Now, we move forward muna sa propeller twist na I think na-mention ko na sa ating previous lessons, but we would get into detail. Ano nga bang propeller twist? Okay. Recall. Why do we twist propellers? So this is again to compensate for differences in rotational speed and provides a relatively even distribution of the thrust along our blade. So kapag tinwist natin yung blade, we get a relatively uniform angle of attack across the entire propeller blade. So, andyan na papasok yung ating mga stations, just like what we had discussed last time. And dito din papasok yung tanong na, how does acceleration occur naman? So, the simple idea behind the acceleration is that the thrust should be what? It should be more than the drag. So, it is done by engine power and propeller RPM. But this has a limitation, syempre, ayon lang sa kung ano yung kaya i-produce ng ating power plant or yung ating thrust available. And as we accelerate, syempre, there is an increase din in drag. So, how do we compensate for this? Syempre, through increasing our power. So, we can say na at higher airspeed for acceleration, need natin ng more power. So, simple as that. Now, when we talk about forces acting on a propeller, so these forces are consisted of both unwanted forces and those na nagagamit natin to our advantage. And we will discuss them one by one. We have the thrust, we have the centrifugal force, we have bending forces, we have twisting forces. First one that we have is thrust. So, thrust is the force that moves the aircraft through the air. It is generated by the propulsion system of the aircraft. And thrust is the air force on the propeller which is parallel to the direction of advance and induced bending stress in the propeller. We already discussed how thrust is generated naman to produce forward motion. Now, the next force is called centrifugal force. So, it causes the greatest stress, this is the most significant force. Force which tries to pull the blades out of the hub. The amount of stress created by centrifugal force can be greater than 7,500 times the weight of the propeller blade. So, that's how significant it is. So, this is a picture that represents centrifugal force. So, yeah, basically, it is a force that tends to pull a body away from its rotation. This force is affected by what? The mass of the body and the speed nga ng ating rotation. More mass or more speed is equal to stronger centrifugal force. So, always keep that in mind. It is because of this force kaya meron tayong limits when it comes to our propeller RPM. So, yeah, take note of this since this is a significant force na nag-act sa ating propeller while in flight. So, for the bending forces, we have two. Thrust bending force and torque bending force. So, thrust bending force, it attempts to bend the propeller blades forward at the tips. This happens because propeller blades are typically thinner near the tip, and this allows the thrust produced at the tip to flex the blade forward. So, again, na-discuss na natin before bakit manipis yung profile na kailangan na, mas manipis compared sa other part ng blade, yung kailangan natin sa tip. But, yeah, meron pa ding consequences. Itong pag-apply natin ng thinner profiles dito, which is in the form of our thrust bending force. Again, this happens because the propeller blades are thinner near the tip, and it allows the thrust produced at the tip to flex the blade forward. That's why you can see the arrows are pointing forward. So it has the tendency to bend forward. Okay? Now, the second one is torque bending forces. As you can see in the photo, it occurs as air resistance opposes the rotational motion of the propeller blades. So this force tends to bend the blades in the opposite direction of our rotation, as you can see evident dun sa ating picture. So let's say it's rotating counterclockwise. So there is a force then na nagbe-bend ng ating blades in the opposite na rotation. So that's it for our bending forces. Okay, sorry about that. So now we have the aerodynamic twisting force and centrifugal twisting force, which are of course the forces under the twisting force. So let's go first sa ating aerodynamic twisting force. It occurs when a propeller blade produces thrust. The majority of the thrust produced is what? Exerted ahead of the blade's axis of rotation. This tends to increase the propeller's blade angle. So, 'di ba kanina na mention natin na may mga forces na unwanted and may mga forces na we can use to our advantage. So, take note na this one, it is used to help change the blade angle on a propeller. So, aerodynamic twisting force, we can use sa ating advantage. Shown in the picture for a variable pitch propeller, ito ha, the part where the center of pressure tends to have greater lift than the trailing edge produces a higher blade angle. Okay? As you can see dun sa picture. Now naman sa second, sa centrifugal twisting force, sa centrifugal twisting force, this opposes aerodynamic twisting force in that it attempts to decrease a propeller's blade angle. So, that's the difference between the two, ha? Sa ating aerodynamic twisting force, we can use it in our advantage while we try to increase the blade angle. When yung centrifugal twisting force naman, it attempts to decrease a propeller's blade angle. When a propeller rotates, centrifugal force tries to align the propeller's center of mass with the center of rotation. So, a propeller's center of mass is typically ahead of its center of rotation. Therefore, when a propeller rotates, centrifugal force tries to decrease its blade angle. Since the leading edge part has more mass, according dun sa ating profile mismo ng airfoil, this force tend to cause a decrease sa ating propeller blade angle. Since mas mabigat nga yung ating part ng leading edge. So, indicated naman siya dun sa ating arrow. Okay? Now that we are done with the forces, syempre kung may forces, meron din tayong stresses. So, we have three. We have bending, tensile, and torsion. So, nandyan naman na yung mga definition nila. So, for the bending stresses, it tends to bend the blades forward and it is induced by the thrust forces. So, the tensile stresses naman caused by anong force? Syempre yung kanina, which tends to pull away, according to nga sa arrow natin, from the rotation. This is caused by the centrifugal force, which again tends to throw the blades out of the hub. And the last one is torsional stress. So this is due to the forces which tends to twist the blades toward a lower blade angle. So those are connected sa ating na-discuss na forces acting. So nagkakos sila syempre ng stress. Now for blade, now we have the blade vibration. Okay. So the first bullet, this occurs because of the mechanical and aerodynamic forces present. Diba we mentioned about aerodynamic force that has the tendency to bend the blades to the tips. Hindi naman agad siya nagbe-bend completely eh. Nagkakaroon muna tayo ng wobbling, syempre, which causes vibrations. So this mechanical vibration naman is brought on by the power pulses in a piston engine. And this mechanical vibration is more destructive kasi it can eventually lead to what? Structural failure. Now, the second bullet, the most critical vibrational stress location is around 6 inches from the tips of the blade. So, sections of the propeller blade could break off while in flight if the metal is overly bent and work hardened due to this vibration. So, especially dito sa mga critical locations na to, which is stated around 6 inches from the tips. So for the third bullet, if a propeller vibrates, whether due to problems with balance, angle, or track, it usually vibrates across the entire RPM range, though the vibration strength can vary with the RPM. Meaning, if maliit na RPM range lang nag-exist itong vibrations na ito, it is not a propeller problem, but from the weak engine propeller match. So, if weak yung ating engine and propeller match, magkakos din siya syempre ng vibration. Now, for the next bullet, when power plant vibration is encountered, it is often difficult to decide if this is the result of the vibration of the engine or of the propeller. Paano ba natin masasabi? From propeller siya if yung hub natin is nagmo-move in a way na nagka-create siya ng little loops. Nagmo-move siya in a little loop. So, from engine naman, kapag yung hub natin doesn't appear to be spinning in an orbit. So, take note of that difference. That's how you can tell if result siya ng vibration ng engine or ng propeller. Now, the last bullet, because vibration of the propeller is the explanation for excessive vibration, the problem is generally caused by instability of the propeller blade. So, untracking of the propeller blade or change in the angle of the propeller blade. Dito na papasok yung ating, di ba na-mention na yung blade tracking. So, we will be discussing it into detail. So, what is propeller blade tracking? Blade tracking is the method of determining the locations of the propeller blade tips relative to each other. The blades rotate in the same rotational plane. So, about the rotational plane and axis, we already discussed it in our first lesson. So, the process of tracking propeller blade tips involves keeping track of each blade tip as it rotates through its arc. You are comparing the position of the propeller blade tips in relation to one another using this method. So, kailan ba ginagawa itong propeller blade tracking? So, you typically check blade tracking during first an inspection when troubleshooting a vibration problem, just like what we connected this into, kasi galing tayo dun sa ating vibration. So, syempre, during an inspection. Or it can either be done then as a final check after balancing and reinstalling a propeller. Okay, so How is blade tracking done? First, make sure that the aircraft is in a stationary position. So, kindly take note of that. Then, place a board on blocks under the propeller arc and taping a piece of paper sa ating board. So, with the reference point in place, let's rotate na the propeller blade. Tapos, imamark natin siya. The second photo, as an example, shows the mark for the track of the next blade. Diba, dun sa unang photo, minark natin siya, then we spin it, then we mark it again. In order for us to have a certain comparison. Okay, so the blades of a, take note of the pictures na nag-change. We have a third and fourth photo right here. The blades of a wood propeller should track within an eighth of an inch. So, now look at the second photo. Let's say, isa sa mga blades natin is distorted. So, what would that give us? That would give us a distance that exceeds our limit, which is, again, an eighth of an inch. So, 1/8 ng inch. But an exceeding distance doesn't necessarily mean na distorted yung blades agad. It could also be because of the propeller is not mounted properly sa ating engine. So, tracking can be an indication of dynamic imbalance kasi basically, if we were to locate the center of gravity and draw the line representing the plane of rotation, makikita natin na hindi siya pantay in the first place. This will cause the propeller to rock back and forth, which is basically, ano yung na-discuss natin kanina? Vibrations. So, diba? Makikita niyo yung difference dyan na pasok sa distance and hindi pasok sa distance. Evident siya dun sa pinaka-propeller na hindi siya pantay. Diba? Now that we are done with the blade vibration, we will now discuss the basic principles of propeller. So we have the four elements that causes or create a twisting or spinning motion around at least one of the three axes of the aircraft. So we have torque reaction, corkscrew effect, gyroscopic action, and asymmetric loading, also known as P factor. So the first one is torque reaction. Torque reaction involves Newton's third law of physics. For every action, there is an equal and opposite reaction. As applied to the aircraft, this means that as an internal engine part and propeller are revolving in one direction, an equal force is trying to rotate the aircraft in the opposite direction. So, torque, or also known as propeller drag, influences roll about the longitudinal axis. Now, to further understand this, we have yung nabanggit nga na Newton's third law. As we know, in order to create thrust, the propeller and internal engine parts need to turn. And as they do, merong nag-exist na equal force but acting the opposite way ng ating action. Yun yung reaction. So, we can say na with more power, more reaction. So, torque reactions are strongest where? Syempre, at high power settings. So, torque reaction is more powerful at, again, high power settings, low airspeed, and high angles of attack. Depending sa ating manufacturer, designs to counter this effect are introduced. May ibang aircraft na design so that their left wing produces more lift when at a perfect cruising speed. This is for fixed wing, ha? Or for fewer models naman, they often offset the engine to counteract the reaction of the weight. So, yun usually yung designs na ina-incorporate to counter itong torque reaction. Kapag naman sa rotary wings, when we when we reach the topic na for helicopter aerodynamics, it will be totally easier to discuss this one since we get the gist na of what we are learning. So, papasok din to sa ating helicopter aerodynamics. Just take note of torque reaction. So, the next thing is corkscrew effect. So, what is corkscrew effect? It is the high-speed rotation of an aircraft propeller gives a corkscrew or spiraling rotation to the slipstream. So, when does this happen? This occurs when the propeller is moving fast but the aircraft is moving slow. Tuwing kailan specifically ito nangyayari? Sa ating takeoff and approaches to power-on stalls. So, how does this happen? Kapag umiikot yung propeller natin to create thrust, syempre, some of the wind tends to spiral around the aircraft, evident dun sa ating picture. This is called the spiraling slipstream. And as this spirals around, it eventually will hit the left vertical fin, which causes the aircraft to what? Siyempre, yaw to the left if left vertical fin natin yung mahahanap, yung matatamaan ng force galing sa slipstream. So, this also causes a rolling moment but is mostly naka-counteract siya ng ating torque effect na na-discuss natin kanina. Kindly take note na when we increase speed, hahaba yung ating spiral. To the point na hindi na nagiging ganun kalakas yung force, kaya hindi na siya nagiging effective. Corkscrew effect is greatest at slow air speeds and high power settings. The next, we have the gyroscopic action. Before the gyroscopic effects of the propeller can be understood, it is necessary to understand the basic principle of gyroscope. All practical applications of the gyroscope are based upon two fundamental properties of gyroscopic action: rigidity in space and precession. The one of interest for discussion is precession, so gyroscopic precession. So what is it? What is gyroscopic precession? It is the resultant action or deflection of a spinning rotor when deflecting force is applied to its rim. So how does the gyroscopic action happens? As the propeller term, somehow nga, para siyang gyroscope. So ano nga ba ang idea behind gyroscopes? Recalling what we studied in physics, a gyroscope experiences a force known as precession every time an external force is applied to it. So, ang force na ito act 90 degrees ahead of the applied force. So, if we apply an upward force to a gyroscope that is turning to the right, we'll get a resultant force that moves the gyroscope to the right. So, how does this, ano bang connect nito? How does this work on our aircraft? Let's say our propeller is turning to the right. Then we apply an upward motion, which is by what? Pitching the nose up. It will give us a resultant force that pushes the nose of our aircraft to the right as well. So, where does this significantly apply? Diba sa example natin, that right motion can be countered naman by the left turning tendencies. Pero when we talk about tail wheel aircraft, they have to pitch down, diba, during takeoff to take the wheel off the ground. This will give them a left turning tendency. So, dadagdag siya sa existing na left turning tendency netong tail wheel aircraft na to. So, diba nasabi nga natin kanina na may force naman na magka-counteract sa kanya, but not every design of the aircraft has this. Okay? So now we have the asymmetric loading, also known as P factor. So this asymmetric loading is induced by the resulting velocity, which is created by combining the velocity of the propeller blade in its rotational plane with the velocity of the air moving through the propeller disc horizontally. So this is a phenomenon that happens because sa certain phases ng flight natin, where we have high power and high angle of attack, may tendency na mag-yaw to the left ang aircraft. Kapag we are in a straight level flight, diba, same ang angle ng downward moving propeller and upward moving propeller natin. Pero when we are not in a straight level flight, let's say, nag-pitch up tayo. Yung downward moving propeller will have a higher angle of attack, making it gain more thrust, hence making the aircraft yaw to the left. So P factor is strongest at high angle of attack, as you can see there. Now we have the seventh topic, which is the propeller pitch. What is pitch? So pitch is the theoretical distance a propeller advances longitudinally in one revolution. So we have geometric pitch and effective pitch. What is geometric pitch? Geometric pitch is the theoretical distance a propeller would move forward if it were 100% efficient. So, saan binabase yung measurement niya? Its measurement is based on the propeller blade angle at a point out from the hub that is equal to 75% of the blade length. Now, anong difference niya sa ating effective pitch? Effective pitch is the actual distance a propeller moves forward in one revolution. So, always keep in mind, geometric is what? The theoretical, and effective pitch is the actual. So, ang pinaka-difference nila is what we call the slip. Pretty much. Slip is just the difference between geometric and effective pitch, which is our theoretical and actual pitch. So, in order for us to understand more, here is our photo, and syempre, meron na tayong problem. So, diba by definition, slip is the difference nga between geometric and effective pitch. So, how do we get geometric pitch? First, we multiply 2 pi r by the tangent of blade angle at 75% station kasi nga, diba, yung sinabi ko kanina na geometric pitch measurement is based on the propeller blade angle at a point out from the propeller hub that is equal to 75% of our blade station. So, again, theoretical siya. Ideal ba? So, yung R natin dito is radius at the 75% blade station. Okay, so we have a sample problem right here. A propeller has a geometric pitch of 50 inches. However, if the aircraft actually moves forward only 35 inches in one revolution, what is the slip? So, take note muna natin, ano nga ba yung mga binigay sa atin. So, we are given the geometric pitch of 50 inches. Let's just take a note here na 50 inches. Then, effective pitch. Ano yung effective pitch natin? 35 inches. Since, di naman nilagay dyan na effective pitch siya, pero, by definition, it is how much the aircraft actually moves. Okay? So, we are required to find the slip. And in order for us to do so, we would apply the idea behind ng ating slip. Ano nga ba yung slip? By definition, it is the difference that we would be getting from the GP minus EP. So, we simply subtract the two we have 50 inches minus 35 inches. Here we would be getting 15 inches as a difference. So to get the percent of efficiency or inefficiency, we would just be getting how much is 15 inches a percent of 50. Kasi nga, ito yung pinaka ang pinaka naging inassume natin dito is 100% yung efficiency ng ating engine when it is in 50 inches na GP. So, kung meron tayong difference na 15, kunin natin kung anong percent ng 50 ang 15. That will give us 30%. Okay, basic math lang to ah. So, that would mean na we have 30% loss of efficiency. So, meaning ang ating engine ay gano'n lang ka-efficient? 70% efficient lang siya. Okay? Again, sorry for the hideous handwriting. So, again, in this case, the slip represents 15 inches or a 30% loss of efficiency. We just subtracted EP from GP, then get it in percentage to get the percent loss in efficiency. Okay. So, yeah, ang kinukuha pala dito is slip. So, yeah, 15 inches, 30% is the loss in efficiency. So now that we are done with the propeller pitch, we would now be moving forward sa ating last, but I think this specific topic is quite a bit long. So we have the propeller design. So this part prescribes airworthiness standards for the issue of type certificates and changes to those certificates for propellers. So here are some notes from this part, specifically the part 35 airworthiness standards for propellers. For subpart A, the general, so it fall instructions and propeller ratings and operating limitations fall under this subpart. So for the instructions, we have anything that we will be needing for the installation of propeller, including description, functions, limiting conditions. Sorry about that. Hydraulics and etc. So we also have here the under the instructions yung operation ng ating propeller. So 35.5 propeller ratings and operating limitations established by applicant approved by our FAA. So power and rotational speed, takeoff, maximum continuous overspeed, and over torque. So andyan siyang part. For subpart B naman, andito yung for design and construction. So we have safety analysis. So under nito yung propeller system failures and the hazardous propeller effects. Under nun yung development of excessive drag, significant thrust in opposite direction to that commanded by the pilot, release of propeller or any major portion, and the excessive unbalance. So another under nung ating safety analysis is yung major propeller effects for variable pitch propellers. And under niya, inability to feather, inability to change pitch when commanded, significant commanded change in pitch, significant controllable torque, or speed fluctuation. So that's it for the subpart B. Now, still under subpart C, we have, for the test and inspections, we have the lightning strike. We have the endurance test, and under that, we have fixed pitch and ground adjustable propeller. And yung the ones that are performed sa ating variable pitch propellers. So, yeah, pretty much that is it. That's pretty much self-explanatory na. Since airworthiness standards lang din naman to. So, yeah, yun lang yung nagpo-fall under ng ating propeller. Sa subpart C pa din, we have 6 and 7, which is for functional tests and overspeed and over torque. Okay? So just kindly read through this. There are two theories involved in propeller design. So, we reached the part na medyo magko-compute na tayo. So, the first theory is momentum theory. So, yeah, momentum theory. So, bakit nga ba papasok ang application ng momentum theory? So, thrust kasi is comprised of two components. Meron tayong tinatawag na pressure thrust and momentum thrust. Among the two, yung mas important is yung momentum thrust. Bakit? Kasi this is the one responsible for creating the thrust that your aircraft needs. So for momentum theory, we have assumptions. The first one, propeller is replaced by an actuator disc which is porous, relatively thin, and has no mass. So parang we are assuming that we are dealing with an actuator disc. So later on, I will show a figure. Pero yeah, one of the assumption, always remember for momentum theory, is actuator disc siya. So may tendency na meron tayong mga aspects na hindi natin mako-consider for this theory. The next is the disc provides no resistance or drag on the flow. As I've told you ngayon lang, meron tayong mga hindi mako-consider na aspect. And yun, we are assuming that the disc provides no resistance or drag on the flow. It contributes no drag. The next one, no abrupt changes in velocity across the disk, and velocity is uniform and smooth across the actuator disk. And yeah, the working fluid is compressible. That's why kapag you try to look into the process of derivation. So kapag gumamit tayo ng Bernoulli's theory and at the same time yung ating continuity equation, kasi pretty much dun lang iikot yung ating derivation nun eh. Dun lang nagmumula yun. And together with the figure that I would be showing you later on. So dun lang magmumula yung derivation niya. It would definitely take most of our time if I like focus into detail pa yung pinaka-derivation niya. But regardless, I would be providing siguro references na lang. Pero yeah, I would be stressing out kung alin lang yung mga equations and formulas that you need to focus on. Okay? So, the next assumption is static pressure at far upstream and far downstream is equal to atmospheric pressure, but with varying velocities. So, paano natin i-explain yan? The next slide. Okay. Okay, so this is the figure that I was talking about, this slide. So, as you can see, dun sa pinakababa, is disk. Talagang literal na disk yung ating ina-assume na shape ng ating propeller there. And makikita nyo na meron tayong upstream and downstream conditions. So, yung pretty much relationship ng pressure, velocity, and area, you can see there. Pero again, as I've told you, sa derivation nito, ang i-apply lang natin pretty much is yung idea na first, Bernoulli's theory. Take note na incompressible yung flow na ina-assume natin. Bernoulli's theory, continuity equation, and probably I'll go ahead and make na lang a separate video for that para hindi masyadong mahaba tong video na to. Okay? So, ayan. And i-apply din natin dun at the same time yung idea na trust is a force. So, may mga ideas na concepts na manggagaling dun. And basic algebra lang yung gagamitin natin to derive. But as I've told you, I will be stressing out lang kung ano yung mga equations na may encounter nyo na pretty much sa momentum theory nga, hindi nyo siya masyadong ma-encounter like sa activity talaga. More on blade element kasi yung ina-apply doon. Pero this is for the momentum theory, which deals for determining ideal efficiency. So the first one, propeller efficiency, it is denoted by lowercase eta. Okay, so again, yung pinaka derivation nito would be discussed separately. But yeah, you pretty much have to focus it lang. And to apply the idea of this formula, we would be having sample problems naman. So the second is thrust in terms of propeller efficiency and the coefficient of thrust. So kindly take note of these formula. Now, we would be proceeding na sa ating sample problem para kasi mas magigets nyo to kapag, syempre, hinainan na kayo ng problem before you. So, let's practice this out by using sample problems. So, our sample problem, using the momentum theory, what is the maximum efficiency obtainable from a propeller if the airspeed is 150 miles per hour and slipstream velocity is 185 miles per hour? So, syempre, as engineering practice, we would be listing out the given first. So, sorry for the ugly handwriting again. The given first is slipstream velocity, which is 185 miles per hour. So, V slipstream 185 miles per hour. Tapos, sunod is yung airspeed. Which is 150 miles per hour. I hope maintindihan niyo sulat ka pound. But anyway, anong pinaka-required natin dito? Maximum efficiency. So, we are required to get the propeller efficiency. So, for the solution, we would go back dun sa formula kanina. Balikan nyo na lang sa kabilang slide para mas malinaw. But it pretty much says that propeller efficiency is equal to 2 over 1 plus the ratio of our V slipstream over V airspeed. So, we would be having propeller efficiency. Substituting our values, we have 2 1 plus what is again our velocity in the slipstream, so 185 mph, and the velocity airspeed pala is 150 mph. So in percentage siya, so ano nyo na lang, i-multiply by 100. But if you try to calculate this, sorry for the noise. But ayun, if you try to calculate this, you would be getting 89.55%, if I'm not wrong. So, propeller efficiency is about 90%. So, ano naman, kapag in case naman isama to sa problem, I would be telling you naman kung ilang decimal places or significant figures yung hanapin natin. But anyway, yeah, that's pretty much, this is momentum theory, easy pa lang naman to. Magkakaroon tayo ng more complicated pagdating ng blade element theory. Pero regardless, mamamaster nyo naman yun as you do the activity, since yung mga formulas that you would be discussing sa blade element are the ones that you would pretty much be using sa inyong activities. Okay. Okay. So we have here the question, what is blade element theory? So pretty much, i-compare lang natin siya sa momentum. Since for this one, meron din tayong assumption. So, unlike the momentum theory, this theory take into account the shape of our blades. So, hindi na same yung assumption natin na actuator disc lang yung dinidil natin. So, the blade is divided into small sections for the blade element theory. These sections which are handled independently of each other. Each blade has its own respective blade angle, its own chord, its own radius, and syempre other airfoil characteristics. Ma-appreciate nyo to kapag ginagawa nyo na yung activity. So, the blade element theory works well for light-loaded 2 to 3 blade propellers, except near the hub. So, foundation of this theory is pretty much the airfoil wing theory. So, ang assumption natin, kindly remember na lang, the assumption for blade element theory natin, 2D lang yung flow. So now, for blade element theory, we are concerned na sa efficiency, syempre, when we compare this to the, what you call this, momentum theory. So, the efficiency of an element, kasi diba, according to the assumptions for blade element theory, may mga elements na nagko-comprise sa ating pinaka-blade. Parang may mga sections. Okay, so hinahati-hati siya. So the efficiency of an element, again, represented by lowercase eta, we can solve this by using the tangent of the angle between the resultant velocity and the propeller disc all over the tangent of the sum of the two angles, the angle between resultant velocity and propeller disc, and the angle between the resultant force is acting in a different direction from the lift component. So, to further understand that, we have a figure right here. So, here in the figure, as you can see sa baba, diba may 2 pi rn dyan. 2 pi rn represents our, what? Rotational velocity. Kaya, meron tayong radius na component dyan. So, yung V na pataas, it represents our flight speed. And yung V sub R naman represents yung resultant speed ng ating two vectors, which are the flight speed and yung rotational speed. Anyway, na-show ko naman na to nung lesson 1, diba? Yung pinaka 3D niya, yung merong two vectors. Ito lang yung mas detailed. So, the forces present are, of course, thrust and torque. But for this theory, focus on the angles as they are needed for the efficiency. As you can see, right there. Just for this part, okay? So, nandyan yung angle between resultant velocity and yung theta. So, if the same airfoil section is used at the same angle of attack throughout the blade, theta will be constant. So, we would be using this formula wherein you would be able to get the angle between the resultant velocity and propeller disc by subtracting half of the angle between the resultant forces acting in a different direction from the lift component. So if you subtract that from 45 degrees. Okay, to further understand the relationship between the two angles, let's have an example. So for clockwise section, Take note ha, clockwise section is the certain section that we would be using when we proceed na to the propeller construction. So it is used frequently for propellers. So the maximum lift to drag ratio is 22.5, making theta have a value of 2.5. Then the maximum efficiency will be, yan, as we use nung formula na ating given kanina. So for the efficiency naman, you would be able to use the formula for the bleed element theory efficiency. Again, what does this mean? This will be the most efficient element within our propeller. Nearer to or farther from the tip blade elements will be less efficient. Imagine having to test each section. Diba na-mention na it has infinite numbers of airfoils for our blade element theory. Kasi nga, section siya, sinection natin siya. So this makes this process time-consuming. So you just have to be lightly familiar with this one. Again, we would be able to tell the most efficient na element. Now, we move forward to determining thrust and power. Okay, so we have the advanced ratio. So it describes the conditions under which the propeller is operating. So we can get this. It is represented by J, and we can get this by the formula V over ND, where V is in feet per second, N is the is in revolution per second, or may problems din given siya in RPM. But regardless, we can convert it naman. So D is the diameter in feet, and to get the thrust, which is represented by T, we have this formula. And power absorbed naman, we have this. And for the efficiency, this one. So you can have it either in terms of TV over P or in terms of advanced ratio. So if you're wondering, yung CT dun is the thrust coefficient and yung CP is the power coefficient. So note that in determining thrust and power, take note of these formulas. So ito yung gagamitin natin. So note that the blade elements inside 20% of the propeller radius contributes no thrust at all. So sa activity nyo, huwag kayong magtataka if, though i-explain ko naman yun sa activity separately, huwag kayong magtataka usually kapag ang stationing natin rather is mag-uumpisa saan? Sa 20% na ng ating radius. Bakit? Kasi yung elements before that is proven to contribute no thrust at all. So, to withstand centrifugal forces, the blades are extremely thick near the hub and are consequently very poor airfoil sections. So, I believe na-discuss ko naman sa lesson 1 which part contributes most thrust, which part is the thinnest and the thickest. So, to further understand how do we apply this, let's have, syempre, a sample problem. Okay, so here is our sample problem. I hope kita, no? So, a 9-feet diameter constant speed propeller whose performance is as seen in the figure below, I would be showing you the curve later, is on an engine rated at 500 horsepower at 1900 RPM and 10,000 feet altitude. So the airplane is flying 10,000 feet altitude at an airspeed of 180 miles per hour. So what is the thrust and the propeller efficiency? So again, engineering practice, we have to list down the givens first. We have the diameter, 9 feet, the power absorbed in horsepower, So we have n in 1900 RPM. The velocity is 180 miles per hour, and the altitude is given to yung 10,000 feet. So required natin is thrust and the efficiency. Okay, so kanya-kanya naman tayong practice when solving a problem. But for me kasi, gusto ko na para tuloy-tuloy yung aking pagsosolve is kino-convert ko na first yung mga dapat i-convert. Kasi diba sa formula, as I gave you the formula a while ago, binigay ko naman kung ano yung units na magtutugma, yung units na kailangan if ever. So, yeah, diameter is in feet. So, tama siya. Wait a second. On ko lang yung pen. Okay, so tama siya. We would use that in feet. Yung ating power absorbed is in horsepower. So, we need that sa unit ng foot-pound per second. So, how do we convert this? We just simply multiply this by, 550. Wait nga. Erase natin. Pangit. Okay, erase natin. So, we'll try to write it better. So, we convert it to foot-pound per second by multiplying it by 550. So, we would be having 500 times 550, we would be having 275,000, I think. 275,000. Ano na yung unit niya after natin i-convert? Foot, pound per second. So, check na siya. And the next, di ba kanina, I told you na may problems na mag-give sa inyo ng RPM. So, just simply convert this by multiplying it to cancel yung ating minute. We have, kasi di ba revolutions per minute yan. So, nasa baba yung minute yan. So, 1 minute is equivalent to 60 seconds. So, maka-cancel out yung minute, which would give us 31.67 RPS, revolution per second. So, you need the velocity to be in foot per second. So, to do that, multiply it by, alam nyo na to, at least you should know that by now. Multiply it by 22/15. Alam nyo na yan, sinapuso nyo na yan. So, you would be getting 264 feet per second. So, check. So, binigyan tayo ng altitude. Yung gagawin natin dyan. So, ano ba yung part na kulang according dun sa mga formula natin? Bakit may altitude? Hindi naman natin gagamitin yung altitude. So, saan siya papasok? Siyempre, density. Diba? Wala tayong given na density eh. So, we would be getting the density from the altitude. So, saan manggagaling na naman yung formula? Siyempre, diba, yeah, you would be able to get the density using, we would get the density at 10K altitude by using yung pinakamamahal nating formula, density sub O plus 1 plus, no, not plus, sorry. Nadala magsulat, okay. Okay, density times 1 plus AH over TO. Substituting our value, meron naman tayo niyan, sea level conditions lang. So, 0.002377, which is our density sub O. Tapos, 1 plus A in English, which is what? Negative 0.003566. So, I expect na kabisado nyo na yan. Multiplied by our 10K na altitude, hindi na inaabot. Okay. So, all raised to 4.26. All over, ano pala to? ang ating temperature. Okay. Run kayo. So, yeah, we would be getting what is our density in 10K. Again, I'm so sorry with the ugly handwriting. Pero you can use the module din para mas madali siyang sundan. Pero our density at 10,000 feet is, we solved it as 0.001755 unit. Siyempre, for density is slug per cubic feet. Okay, so now that we have our density, kasi part siya nung pag-solve ng ating thrust. So that again is pretty much before, pre-step lang to bago mag step 1. I suggest you again, iba-iba naman tayo ng practice, pero sa akin kasi mas okay na kina-convert muna yung mga given para isang convertan na lang siya. So, okay. So, ito yung problem ulit. So, the first step is to get our CP. So, recalling kanina, ano ba yung formula na merong CP na component? So, as you can remember, sa power absorbed siya. So, ano ulit yung formula ng power absorbed? That's density multiplied by CP multiplied by N cube multiplied by our diameter raised to 5. So, we try to put CP on the other side. We would get our power absorbed all over kanina tira, density N cube d raised to 5. So, if we try to plug in our values, meron na tayong power absorbed kanina, meron na tayong density at 10,000 feet, meron na tayong N, meron na tayong diameter. So, try to follow the discussion, ha? You can use your calculator. Mas maganda, actually, if you try to follow it. Para may scratch din kayo dyan and all. So, we would be getting our CP is 0.0835. So, anong next step natin now that we have our CP? The next step is to get our advanced ratio. So, how do we get our advanced ratio? Ano ba yung formula niya? Diba? Advanced ratio is equal to V over ND. So, meron na tayong velocity na convert na natin siya kanina. So, balikan natin siya. 264 feet per second all over yung na-convert naman natin na RPM to RPS, which is 31.67 RPS multiplied by, syempre, yung diameter natin, 9 feet. So, our advanced ratio is 0.9262. So, we can say na our advanced ratio is about 0.93. So, ma'am, bakit, di ba, kailangan mas accurate yung sagot? Usually, 4 to, minsan nga, lahat nung nasa calcu, pinapasulat kapag ganyan. Pero kasi, bakit dinalawang keep it simple as I can? Kasi, ang ating advanced ratio, gagamitin natin siya for identifying the value of our coefficient of thrust using a curve. So, as we utilize the curve, we try to what do you call this? Round it off para mas madali siyang makuha na ng value sa curve. So, ano nga ba yung sinasabi ni ma'am? So, malalaman yan sa next step. As I've told you, malalaman niyo yan sa next step. Ano nga ba next step ng solution natin? So, get the thrust coefficient from the power coefficient curve. Ano nga ba yung power coefficient curve? So, for reference, you can use your module or you try to center it out in CAD kasi I don't know kung kasi yung reference na pinagbasihan nito is quite an old book, but it is actually good. Yung link nun nandun naman sa module if you want to practice kasi may mga sample problems dun, I believe. More sample problems. Pero yeah, that is our curve. So the next thing is to get CP from the power curve, power coefficient curve. So as you can see, diba, merong advance ratio over here na nasolve na natin. And yung component naman natin dito is CP na sinolve din natin kanina. Diba? So that makes sense lang na we would use V and D, which is our advance ratio and our power coefficient to get our thrust coefficient. So again, what is our advance ratio? So 0.93. So if this is 0.8 and 1, so that would fall just right right there. Okay? So our okay, ang ating CP is 0.0835. 0.835. So that would fall somewhere here. Somewhere here. So if you try to project it, we would assume na at the point na pinagmitan nila, which is, again, hindi ko pala namarkahan yung sa advance ratio. So that is somewhere near here. Just before it reaches 1 kasi nga 0.93. So if we try to project it out, mas maganda nga siguro kung may CAD, ano po. So it would fall somewhere here. In this region, somewhere there. So, we can say na malapit siya sa 0.08 and magfo-fall siya under what blade angle? Ayun o. Yun. So, again, a bit, we can assume na muna the value of our CT. So, CT is around what? 0.074, 0.075 is around that. So, ang ating blade angle is 25 degrees. So, we now have the value of our thrust coefficient and our blade angle. So, ano na nga ang next step natin? Our next step is to get our thrust. Kasi kompleto na natin yung mga parameters na kailangan. So, paano nga ulit kunin yung thrust? So, thrust is density multiplied by our thrust coefficient and cube d4. So, substituting our values, we have yung density na nasolve natin kanina at 10K, 0.0001756, I think. Then, yung ating thrust coefficient, which is the one that we have kanina sa curve, 0.074. Yung ating N in RPS, which is 31.67 RPS multiplied, it's, if I'm not mistaken, it is, actually mali yung nalagay ko dito. Hindi pala siya, to siya, sorry. So, squared lang to. Multiplied by, ano pang kulang? Diameter, 9 feet. Raised to 4. So, If we try to put that in our calculator, we would be getting our thrust to be 855.1108 pounds. Okay. So our next step is to get the efficiency, since we pretty much solved for 50% of what is required of the problem. We have our thrust na. We only need to get the efficiency. So, anong formula gagamitin natin sa efficiency? So, syempre, yung merong advance ratio, kasi meron tayong advance ratio, multiplied by our thrust coefficient over our power coefficient. Kasi meron na tayo yung tatlo eh. So, that would give us, again, our advance ratio is 0.93. Our thrust coefficient is 0.074 and our power coefficient is 0.0835. 0.0835. So right there, we would be getting our efficiency of, it's always in percentage unless otherwise stated by the problem, for 192%. Okay, so yeah, for clear version, you can do it together with the module. Pero yeah, we are able to utilize our formulas. Balik-balikan nyo lang, practice. Practice is the key lang. Madali lang siya, guys. Ano lang, diba? Pretty much direct substitution lang din talaga siya. So right there, we successfully solved for our problem na. No worries naman. Magiging kompleto naman yung instructions ko, and I would be considerate naman as I check if ever magbigay man ako nito sa nasusunod na exam or sa quiz. But pretty much, you just have to be familiar with the process. Kasi gagawin nyo yan sa activity. Gagamitin nyo. Okay. So, the available horsepower, engine revolutions, and airspeed being known, the power speed coefficient, also known as CS, may be found. So, saan natin gagamitin yung CS? Ito yung formulas. Ano yung napapansin nyo dyan? Diba? Wala siyang diameter. Kasi in the preliminary design of a propeller, it would be helpful to have a formula for power not involving the diameter, which is not usually known at the beginning ng problem. So, si weak, you can find this ni F.E. Weak. He introduced the power speed coefficient. Okay. So, anyways, ma-apply din naman natin yan sa as we move along our topic. Okay. So, now that we are done with determining the thrust and power, how do we determine the blade angle and diameter? But first, ipakita ko muna sa inyo yung mga curves na ating ma-encounter. So, we have this figure right here, efficiency versus CS for various bleed angles, and CS versus bleed angle in various advance ratio. So, to further understand, we would be using these sa ating next na sample problem. So, here is another sample problem wherein pretty much ikot siya sa bleed angle and efficiency. So, a cabin monoplane has a top speed of 150 miles per hour. Its engine gives 400 horsepower at 1900 RPM. So, find the diameter, bleed angle, and efficiency of the propeller for general utility. Now, we have another scenario. Pinapasolve naman what is the efficiency if the airplane flies at this speed, which is 100 miles per hour and 1600 RPM. We also have our CS, which is 1.40. So first, we list down our given, and just like may practice nung previous na problem, syempre, convert na natin siya para hindi na tayo mahirapan later on. So for velocity, again, alam niyo na yan, multiply by 22/15, that would give us 220 feet per second. So, power absorbed naman, again, multiply it to 550 in order for you to have, what? I think that's, yeah, it is, wait lang, 220,000, I think. Oh, sorry. Foot, pound per second. So, ang N natin is naka-RPM. So, we need it in RPS. We just divided by 60, we would just be having 31.67 RPS. And convert this also to foot per second, we would be having 146.67 foot per second. And our N, we need it in RPS. I'm sorry, RPS. Yeah, we need it in revolutions per second, RPS. So, in order for us to do so, what would we do? Again, we divide it by 60 to convert the minute to seconds. So, we would be having 26.67 RPS. And our CS is 1.40. So, we are required to get the diameter, the bleed angle, and efficiency at 100 miles per hour and 1600 RPM. So, we now proceed sa ating solution. So, ang una nating step is to get the bleed angle from the curve. So, which curve? The first curve na sinow ko sa'yo inyo kanina, but there are two. So, the first one, specifically yung ating efficiency versus CS na curve. So, as you can see, meron tayong efficiency right here and CS right here. So, how would we get it? Diba we have our CS given kanina, which is 1.40. So, we project it up, then we find which curve natatapat siya sa peak nung curve na yun. So, we have it somewhere between 18 and 20. Since yung peak ng 18 is nandito, hindi siya katapat ng 1.4. And yung peak ng 20 is nandito, hindi rin siya katapat ng 1.4. So, yeah. So, that is our bleed angle, which is around 19 degrees. And how would we get the efficiency? If we try to project it here. Kasi diba dito yung efficiency? So, this is somewhere around there. So, as you can see, the increment is, I think, 0.01. So, 0.80 minus 0.01. So, that would give us the efficiency of 0.79. So, peak efficiency ng ating 19 degree na bleed angle is C, 0.79 na efficiency. Now, ano nang kasunod nating step? We have our bleed angle na. So, we need to get what? What is our second required? The diameter. And in order for us to do so, we would first get the advance ratio from the second curve. So, curve 2.27, which is the CS versus the bleed angle in various ND. So, how are we going to find the VND or the advance ratio? So, diba, we have our CS nga kanina, which is 1.4. And na-determine na natin yung blade angle. Diba, we have our blade angle right here. We have our CS right here. So, if we project them both and try to get where they meet. So, this is, start natin dito sa CS na 1.4 natin. Tapos mag-meet sila nung 19 around here. Yeah, around here. That is pretty much middle ng 0.70 and 0.75. So, we can say na ang ating advance ratio is 0.725. Okay? Now that we have our advance ratio, what is our next step? Siyempre, get the D. Okay. Get the diameter. So, going back, what is our formula for advance ratio? It is V over ND. Diba? So, we try to put diameter on the other side of the equation. We would have V over advance ratio times N. So, substituting our value, we would have our velocity na convert natin kanina, yung 150 miles per hour na convert natin sa foot per second, na we got 220, diba? 220 foot per second. Then, all over yung ating advance ratio, which is, we got from the curve, 0.725 multiplied by our N in revolutions per second, which is 31.67 RPS. That would give us a diameter of 9.57 feet. So, now na nakuha na natin yung ating bleed angle and diameter. What next? So, pretty much ang next natin is to get the efficiency of, diba, itong given na scenario na ito. But in order for us to do so, we would need to get the advance ratio para pretty much makuha yung CS bago makuha yung efficiency. So, for us to get the advance ratio, diba, we have advance ratio is equal to, again, V over ND. So, yung velocity is, which is yung 100 nga, na kinonvert natin kanina, diba, naging siyang 146.67 feet per second. So, yung RPM niya na kinonvert natin kanina, which is 26.67 full, sorry. Okay, sorry. Asan yung eraser? Try to erase that. Okay, going back. Kinonvert natin siya to revolution per second. And yung diameter naman natin, di yan nag-change. So, what is the diameter that we have kanina? 9.57 in feet. So, that would give us the advance ratio of 574. So, now that we have the advance ratio, we would be able to, what? Get the CS. Okay, so going back, what would we need ba in order for us to get the CS? First is, syempre, yung, yung component natin here, which is blade angle in degrees, and yung component natin here, yun yung kunin natin, CS. Pero ano nga ba yung isa pang makikita dito sa curve na ito? Ayun, may VND din dyan. So, if we try to, alin nga ulit yung ating bleed angle, according kanina. So, it is 19 degrees and yung kakasolve lang natin advance ratio is 0.574. So, we try to use those values to get CS. So, if we try to search yung ating advance ratio na 0.574, naka-curve siya dito between 0.55 and 0, somewhere between 0.55 and 0.6. So, most certainly, mas malapit siya sa 0.55 kasi 0.574 lang siya. So, ano yung component magiging katapat niya when we project it with 19 degrees to be the blade angle? So, it would fall around here, asa na? Okay, 0.55 and 19. So it would fall somewhere here. And if we try to project it down, somewhere siya malapit na sa 1.1. Okay? So we can say na our CS is, we can assume it to be 1.08. Okay? So now that we have our CS, so what is the next step? So the last step is get the efficiency from the curve using what? Diba? May anong component to? CS and efficiency. So we need to get the efficiency. How? Ano ba yung given dito? Blade angle. So that's it. So our blade angle is again 19 degrees. And our CS is yung kanina natin na solve for this particular scenario, which is 101.6, which is 1.08. So we would be having our efficiency for that to be at around 0.75. Okay, so that ends the problem, and at the same time, that ends din the presentation. So, if you have any questions, I'm open naman for questions and concerns during consultation hours. So, thank you for watching this. I know the video could be quite long, almost 2 hours nga, but yeah, practice makes perfect lang, guys. So, practice and practice for the problem. Thank you.